आपका हृदय इतना साफ है कि जो चीज बताते हैं क्रिस्टल क्लियर हो जाती है, फिर 100 लैंग्वेज में बदलो उसको। ये एक ध्यान अगर बंदे का हो जाए तो जीवन ही बढ़िया हो जाए, ये मेरा मानना है सर। So sir, all lecture we have to the put on the YouTube, and live we can also connect some of the person, because I know that lecture is the precious, so I want in the compact manner. As you like sir, 30-45 minutes, this is up to you. What I want in the compact manner, so that individual person they can listen the application as well as the utility of this lecture. So thank you very much, Dr. Balakji. Please proceed.
Okay, thank you, sir. So good afternoon to respected Dr. R.K.Maheshwari, sir, respected director, sir, and my colleagues. We have among us Professor Dr. R.K.Maheshwari, sir, from SGSITS in Indore, and we all know him very well for his very famous work solubilization by hydrotropy. And I have also the audience of Dr. R.K. Maheshwari sir lecture in various institute. So I hope that this is the 328th lecture of sir for on the hydrotropy. So please sir continue. Please share your slide.
फर्स्ट ऑफ ऑल मैं सबसे पहले सहृदय से अपने गुरु जी को प्रणाम करता हूं, नमन करता हूं, और सहृदय से ISF परिवार की ओर से आपको बहुत बहुत स्वागत करता हूं। एज डॉक्टर बालक जी मेंशन दैट 328 एंड आई हैव सम ड्रीम सर टू वॉच टू यू, एंड आई वांट के वो दिन मैं देखना चाहता हूं जब महेश्वरी जी एक ही टॉपिक पर 1001 बार लेक्चर दूं और मैं उसका दार्शनिक बनूं, दर्शक बनूं, मेरा सौभाग्य होगा सर। इस सीरीज को रोकना नहीं है सर, रोकना नहीं है, ठीक है। ये सर मेरे लिए जब भी आप बताएंगे 10, 50, 25 लेक्चर आई विल ऑर्गेनाइज, ठीक है, अलग अलग इंस्टीट्यूट से जहां हमारे MOU हैं, बिकॉज आई वांट टू डेवलप दिस टाइप्स ऑफ द थिंग। सो दिस इज द वन ऑफ द बिग अचीवमेंट ऑफ द इंडिविजुअल टीचर to define and delivering that one types of the only the lecture in a very specific and scientific manner, utilizing the technology, and every day and every month he is the adding something is the new. So thank you very much for accepting our invitation and provide this opportunity to interact with you, and also today we can listen the lecture related to this one, and I also come to know some of the new learning with the hydrotropic solubilization, solid solvent, like that. So I request to Dr. Maheshwari ji, please proceed.
Okay. Firstly, I would like to thank Dr. G. Gupta, Dr. Balak Das, Kurmi ji, and all of course the teaching faculty members of your college, because of whose effort I am here to discuss new research ideas in the field of solubilization. So let me first explain what new things you will get in my lecture. Then I will start my lecture. Up to this time, actually, what we know, whatever the substances exist in the form of liquid, they all are known as solvent, as we know, chloroformethanol, methanol, water, DMSO, etc., etc. So whatever the substances they exist in liquid state, they all are known as solvents. But there is no solvent which is the universal solvent. Whatever the name of any solvent you take, that solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. Similarly, now what happens in the dissolution? Suppose you dissolve, say, sodium salicylate in water, you get clear solution of sodium salicylate in water. The simple mechanism of dissolution is due to hydrogen bonding and weak van der Waals forces between the molecules of sodium salicylate and molecules of water. If you dissolve something in ethanol, say for example ibuprofen in ethanol, due to hydrogen bonding and weak van der Waals forces, there is a dissolution of ibuprofen in ethanol because of hydrogen bonding and weak van der Waals forces between the molecules of ethanol and molecules of ibuprofen. So basic mechanism of dissolution is usually the hydrogen bonding and weak van der Waals forces between the molecules of solute and molecules of solvent. Now similarly, now if you put the molecules of gas or molecules of solid in liquid state by any way, I will explain in what way we can have them in liquid form, these molecules of gas or molecules of solid. then these molecules are also possessing the capacity to make the hydrogen bond and weak van der Waals forces between the molecules of solutes for their dissolution. For example, in case of gases, in supercritical flow technology, CO2 gas at a particular pressure and temperature is liquefied. So, in liquefied condition of CO2, the molecules of CO2 are in liquid state, and we perform different operations like nanoparticles preparation, extraction of active constant from herbal powders, or you may say the purification of the materials and so on and so forth. So, ultimately, a gas, the molecules CO2, when they come in liquid state, they also possess capacity to make hydrogen bonds and weak van der Waals forces with the molecules of solute. Okay, so what we are understanding, the gas molecules when they are in liquid state, they also have got capability to make hydrogen bonding weak van der Waals forces with the molecules of solute. Similarly, another example of gases is concentrated hydrochloric acid, which contains about 38% weight dissolved HCl gas. In this concentrated HCl gas, the solubility of nalidixic acid is about 5%. 5% means very good solubility of nalidixic acid in water. In this concentrated HCl. Otherwise, this nalidixic acid is a poorly water-soluble drug. Now, the reason for good solubility of nalidixic acid in HCl, concentrated HCl, is as a result of hydrogen bonding between the molecules of nalidixic acid and molecules of HCl, gas, dissolved gas. So, whenever the molecules of gas, they are in liquid state, they also possess the capability to make hydrogen bonding weak van der Waals forces. So, in other words, you will say gas molecules also have got solubilizing power. In my lecture, mostly I will emphasize on the solubilizing power of economic and safe solids, which can replace harmful organic solvent. So, this shall be the main objective of my lecture, that how can we minimize the use of harmful organic solvent by utilizing the solubilizing power of safe and economic solids. Now I am going to start my lecture in the form of PowerPoint presentation, and if you have any questions, please note down your questions. At the end of the lecture, we can have this question answer session if time will permit. Okay.
ना वो हो रहा हो गया अब क्या करो यहाँ से स्लाइड शो में जाइए यहाँ से
okay now so today's of course the topic was economic and eco-friendly techniques in various fields of pharmacy utilizing solubilizing properties of safe and economic solids using mixed solvency concept, and this topic which is before you, this is also more or less same. Solubilizing properties of solids shall replace harmful organic solvents. Now, since this lecture is going to be to be observed by the students, so let me explain where these organic solvents are involved. Various organic solvents are employed in various analytical techniques like TLC, HPTLC, HPLC, UV analysis, diemetry, etc. Also, organic solvents are involved in extraction of active constituents from herbal powder, in the synthesis of organic compounds, in the formulation of pharmaceutical dosage forms, etc. Now, the types of organic solvents. First, we should understand what are the drawbacks of organic solvents. Organic solvents have numerous adverse effects caused by single exposure like dermatitis, headache, drowsiness, nausea, irritation, etc. Single exposure means suppose we are performing any practical with some organic solvent, so there may be headache, etc. like this. These are the reversible things. But long-term exposure causes serious ill effects such as neurological disorder, chronic renal failure, liver damage, neurosis, mutagenesis disorder, etc. Long-term exposure means when a person is constantly exposed to the vapors of organic solvent. For example, day to day, and means suppose he is analytical chemist, so daily he is going to be exposed to the vapors of organic solvent. So this is known as you may say the long-term exposure. So very serious ill effects on the human health, they are there. RNA solvents are costly and their disposal requires a special treatment before they are thrown away. Now there are three classes of organic solvents: class 1, class 2, and class 3. Class 1 organic solvents, they include benzene, which is carcinogenic, carbon tetrachloride. These all are very harmful. Class 1 organic solvents, they cause very, their harmful effect is greatest among all these three classes. Class 2 organic solvents, they are also quite harmful for human health. Commonly employed class 2 organic solvents include acetonitrile, chloroform, toluene, methanol, pyridine, hexane, dimethylformide, etc. Class 3 organic solvents commonly employed: acetic acid, acetone, ethanol, ethyl acetate. Among these three classes, class 3 organic solvents are relatively safer than class 2 and class 1 organic solvents. So sometimes what can we do? We can potentiate the solvent power of class 3 organic solvent to act as class 2, so that we can minimize the harmful effect on the human health. Now, future role of solvent character of solids. This is the basic objective. Solubilizing power of solids shall minimize the use of harmful organic solvents in future. Class 3 organic solvents are relatively safer than class 2 and class 1 organic solvent. We can potentiate the solvent power of class 3 organic solvents by dissolving safe solids in them to replace class 2 and class 1 organic solvents. Dissolution. What happens in dissolution? Dissolution of a solute in a solvent involves hydrogen bonding and weak van der Waals forces between the molecules of solute and molecules of solvent. Mixed solvency concept was proposed by me in the year 2009, first time in the world, and there are two parameters of mixed solvency concept. Number one parameter says that each and every substance, gas, liquid or solid, present in this universe has got solubilizing power. Each and everything means whatever are the number of molecules present in this universe, all molecules possess solubilizing power. But only thing will be there that the molecules of gas or molecules of solid, they should be in liquid state. For example, we know that ice does not dissolve, say, sodium salicylate. But when you melt ice, the molecules of water, they come in liquid state and they dissolve sodium salicylate by hydrogen bonding with one of the forces. So basic concept should be known to us that when the molecules of, whether it is gas or solid, liquid molecules already they are in liquid state. So when these molecules are present in liquid state, they are able to take part in hydrogen bonding and weak van der Waals forces. Once the molecules of gas or molecules of solid come in liquid state, they may also be involved in hydrogen bonding and weak van der Waals forces with the molecules of solute for their dissolution. About solvents, whatever matter exists in liquid state at room temperature is known as solvent. Each liquid or so-called solvent possesses good solubilizing power for some solute and bad solubilizing power for other solute. For example, we know water is not good soluble for each and everything. We know from the books. Water is good solvent for about 1/3 drug. Water is bad solvent for about 2/3 drug. So this statement we have to remember that whatever the name of any liquid or the so-called solvent we take, that solvent possesses good solubilizing power for some solute and bad solubilizing power for other solutes. This statement will be helpful in my lecture to clarify further matter. Similarly, each matter, whether matter is liquid, gas or solid, is known as solubilizer in mixed solvency concept. Means whatever the molecules are there, whether they are the molecules of gas, molecules of solid, all molecules are known as solubilizers in mixed solvency concept. But only the same thing will be there. Whatever the name of any molecule you take, that molecule possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. So similarly, each matter, liquid, gas or solid, is known as solubilizer in mixed solvency concept. Molecules of all solids in liquid state, of course, and molecules of all gases in liquid state also possess good solubilizing power for some solute and bad solubilizing power for other solutes. Now we should learn, or we should firstly have some proof that how can we say that solids have got solubilizing power. So before coming to the application part of solubilizing power of solids to replace harmful organic solvent, we should see some examples or some proof that how can we say solids have got solubilizing power, how the solid will demonstrate its solubilizing power when its molecule will be in liquid state. So there are three ways by which the molecules of a solid may come in liquid state. Number one, by melting. number 2 by dissolution in a solvent, number 3 by making utility common mixture. So now examples of melting. Number 1 example is that of melted urea, means 1 gram melted urea, a clear colorless liquid at 132 degrees centigrade, which is the melting point of urea, has good solubilizing power for dichloronic sodium. 1 gram melted urea at 132 degrees centigrade nicely dissolves 1 gram of dichloronic sodium. This means urea, melted urea has got solubilizing power for dichloronic sodium. What is the reason here? The reason is the molecules of urea, they are in liquid state, and these molecules of urea are involved in hydrogen bonding and weak one hour forces with the molecules of dichloronic sodium. That's why you are having very good solubility of dichloronic sodium in melted urea. The melting point of dichloronic sodium is 283 degrees centigrade. So don't think that dichloronic sodium might have melted at 132 degrees centigrade. No. And suppose there was no solubilizing power in melted urea, then you could have obtained a suspension of dichloronic sodium in melted urea, but you are getting a solution. This is a proof. Of course, we are not making any formulation here, but what we are seeing, melted urea is good solvent for dichloronic sodium. Another example, 1 gram melted phenol at 44 degrees centigrade is very good solvent for nalidixic acid. 500 milligram of nalidixic acid is nicely dissolved by 1 gram melted phenol at 44 degrees centigrade, because the molecules of phenol, they are in liquid state, and these molecules of phenol, they are involved in hydrogen bonding at weak one hour forces with the molecules of nalidixic acid, and there is a large solubility of nalidixic acid in melted phenol liquid. Otherwise, this nalidixic acid is a poorly water soluble drug. We are not talking about any formulation, but we are seeing the proof that solids have got solubilizing power. Another way by which the molecules of a solid may come in liquid state is by dissolution in a solvent. 3 examples are here. Number 1 is that of water. Solubility of ibuprofen in water at room temperature is 0.028% weight by volume. But solubility of ibuprofen in 2 molar sodium benzoate means 28.8% weight by volume. Solution of sodium benzoate is 2.390% weight by volume. So 2.390 divided by 0.028, nearly 85-fold solubility enhancement is there in solubility. Again, what is the reason here for solubility enhancement? The reason is sodium benzoate, which is solid at room temperature, when it goes in solution in water, the molecules of sodium benzoate, they are available in liquid state, and these molecules of sodium benzoate are involved in hydrogen bonding and weak one hour forces with the molecules of ibuprofen, and that's why you are getting large solubility of ibuprofen in this sodium benzoate solution. One more thing you should understand that you see why there is less solubility of ibuprofen in water, due to less extent of hydrogen bonding and weak one hour forces between the molecules of ibuprofen and molecules of water. Limited extent of hydrogen bonding. But since sodium benzoate has come in solution, so these molecules are giving, means they are being involved to have large extent of you may say the hydrogen bonding and weak one hour forces. That's why you are getting large solubility of ibuprofen in sodium benzoate solution. Another example is that of ethanol solvent. In ethanol, the solubility of furosemide is poor. Poor means sparingly soluble. Solubility at room temperature is 1.7% weight by volume, that of furosemide in ethanol. Again, due to limited extent of hydrogen bonding and weak van der Waals forces between the molecules of furosemide and molecules of ethanol. But when we dissolve a solid niacinamide in 15% concentration in ethanol, the molecules of niacinamide, they are coming in liquid state in solution form, and these molecules now will facilitate the hydrogen bonding and weak van der Waals forces with the molecules of furosemide. That's why you are getting large solubility, 5% solubility of furosemide in this particular solution. Okay, so here again you are seeing the solubilizing power of a solid niacinamide. Okay, third is, of course, we are not talking about the formulation part here. Third example is that of propylene glycol solvent. So pyroxicum solubility in propylene glycol is about 5 milligram per ml. Very poor solubility is there due to limited extent of hydrogen bonding and weak van der Waals forces. But when two solids are dissolved in propylene glycol, 10% sodium caprylate, 10% sodium acetate. The molecules of sodium caprylate and molecules of sodium acetate, they are in liquid state. They facilitate the hydrogen bonding and weak van der Waals forces with the molecules of pyroxicum. That's why you get a lot solubility, that is about 120 milligram per ml. 120 divided by 5, about 24-fold enhancement in solubility is there. What we are observing that, of course, we are not talking about the formulation here, but we are seeing the solid molecules when they come in liquid state, they are increasing the solubility of drug. Third way by which the molecules of a solid may come in liquid state is by eutectic formation or eutectic mixture. For example, thymol menthol 10 gram. If you try it with the help of piston motor, you will get a clear colorless liquid which is known as eutectic liquid of thymol and menthol in 1:1 ratio, and the pH of this particular liquid is 6.5. Okay, now this liquid, which is clear colorless liquid, contains thymol molecules and menthol molecules in liquid state, and now you see the solubility in this particular eutectic liquid. Left hand side, for all these compounds, this eutectic liquid is very good solvent. For example, metronidazole benzoate, about 20% solubility. What is the reason? Otherwise, metronidazole benzoate is a poorly water soluble drug. But why there's large solubility in this eutectic liquid? The reason is thymol molecules and menthol molecules, they are in liquid state for what? For hydrogen bonding and weak van der Waals forces with the molecules of metronidazole benzoate. That's why you are getting large solubility in this particular eutectic liquid. Similarly, other atenolol or ornidazole, benzopene, etc. For all these compounds, there is good solubility in this particular eutectic liquid. But if you see the right hand column, cetronidazole less than 5 milligram per ml, poor solubility. Okay, similarly for furosemide, nimesulide, etc. So left hand column compounds good solubility, right hand column compounds bad solubility. You may say this eutectic liquid is good solvent for some and bad for other. So now this eutectic liquid has been proved as solvent, just like our solvent statement we have seen initially in my lecture. So here also this eutectic liquid is good solvent for some, bad for other. That's why it has been proved it is a solvent. And once it is proved that it is a solvent, what does it contain? It contains two solids, thymol and menthol, nothing else. This means thymol menthol molecules have got solubilizing power. Now coming to directly to the hydrotrophic solubilization. Now we have seen how the solid molecules can come in liquid state to enhance the solubility. This hydrotrophic solubilization, which is a more than 100-year-old concept. Some examples of this hydrotrophic solubilization: urea. In the middle of this table, you see urea. It is one of the hydrotrophic agents. Suppose you prepare 60% weight by volume solution of urea and water. This is very good solvent for dichloromonic sodium. The solubility of dichloromonic sodium in this 60% urea solution is about 4.8% at room temperature. Otherwise, in water, the solubility of dichloromonic sodium in water at room temperature is about 1.6%. So 4.8 divided by 1.6, three-fold enhancement in solubility is there. This is one example of hydrotrophic solubilization. Hydro means water. Hydro means water. So this hydrotrophic solubilization relates with solubility enhancement in water or in aqueous solutions only. Means solubility enhancement in propylene glycol is not hydrotrophy. Solubility enhancement in ethanol, propylene glycol, glycerin, chloroform, methanol, etc. is not hydrotrophy. Only in aqueous solutions or in water, when there is enhancement in solubility, we call it to be hydrotrophic solubilization. For example, in this case, what you are observing, dichloromonic sodium has got good solubility in aqueous solution of urea. And what is the reason for solubility enhancement? The reason is due to urea molecules which are in liquid state in this solution, they are increasing the solubility of dichloromonic sodium due to more hydrogen bonding, more weak van der Waals forces like this. Another example of hydrotrophic solubilization, left hand column sodium citrate. If you make 45% weight by volume solution of sodium citrate in water, this solution, in this solution, the solubility of salicylic acid is more than 15%. Otherwise, in water at room temperature, the solubility of the salicylic acid is about 0.3%. Limited solubility due to limited extent of hydrogen bonding and weak van der Waals forces. But when you use this 45% sodium citrate solution, the molecules of sodium citrate are in liquid state, and they will help in hydrogen bonding and weak bond forces with the molecules of salicylic acid, and there is tremendous enhancement in the solubility of salicylic acid in this aqueous system. So this is another example of hydrotropic solubilization, and here sodium citrate is hydrotropic agent, and the reason for solubility enhancement is that molecules of sodium citrate they come in liquid state for hydrogen bonding and weak bond forces with the molecules of salicylic acid. Third example, that of left hand side, if you see sodium benzoate. If you mix 30% sodium benzoate solution in water with by volume, this solution of sodium benzoate concentrated solution increases the solubility of several poorly water soluble drugs like ibuprofen, flurbiprofen, metronidazole, tinidazole, ofloxacin, gatiproxacin, nalidixic acid, hydrochlorothiazide, pyroxicam, etc., etc. So this sodium benzoate solution, which sodium benzoate solution is very good hydrotropic agent, and it increases the solubility of so many poorly water soluble drugs several times. Okay, so these all were the examples of hydrotropic solubilization. Now, you see what is, how can we define this term hydrotropic solubilization? This is a small list of hydrotropic agents. There are a large number of hydrotropic agents, but this is a small list of hydrotropic agent. And now the definition of this hydrotropic solubilization is when there is enhancement in aqueous solubility of a poorly water soluble drug in the presence of a large concentration of an agent, then we call this phenomena to be hydrotropic solubilization phenomena. Now we will see, one more thing let me tell you, those who will see my this lecture, this recorded lecture, and whenever they find some doubt, they can ask me on my WhatsApp number, which will be shown to you at the end of the lecture. Okay, so they can contact me, I will reply their answer. Okay, now coming to the application part. You see, up to this time, what did we see? We have seen that all molecules possess solubilizing power. So particularly now we will utilize the hydrotropic solubilization in the field of analysis to minimize the use of harmful organic solvent. So firstly, we will discuss eco-friendly trichromatic analysis of poorly water soluble drug using hydrotropic solution without using organic solvent. Now, this is the example of furosemide API, IP, BP method, they are same, and IP 2022 also, the same method is there. We accurately about 0.5 gram furosemide API dissolved in 40 ml of DMF, which is a dimethyl furosemide, which is a class 2 organic solvent. When you get clear solution, you will add 2-methyl blue indicator solution, few drops. Then you will titrate with the help of 0.1 molar NaOH solution, and suppose the reading at end point is say x1 ml of NaOH solution. Then you will have to carry out the blank determination. So for this blank determination, you will take another conical flask, 40 ml of dimethyl furosemide, few drops of thermal blue indicator. You will run a 0.1 molar NaOH solution. So few ml or say hardly a small volume of NaOH is consumed for color change or used for end point. Suppose it consumes Y1 ml of NaOH for this end point. This Y1 ml has been consumed by our DMF. So this will be subtracted from X1. So X1 minus Y1, this much volume of NaOH has been consumed by your drug. Using this factor, at the last 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram furosemide. Using this factor, you will find out the drug content of your API. So in this particular, so IPBP method, they are employing dimethyl furosemide, which is a class 2 organic solvent. When you will perform the titration, the vapors will go inside your body. They may go in your body. They will cause harm to your health. You may say, okay. Now I will give the hydrotropic green method, hydrotropic analysis. The same titration can be done in this way. We accurately about 0.5 gram furosemide API dissolve in 40 ml of 30% weight by volume solution of sodium benzoate. And when you get a clear solution, you add few drops of thermal blue indicator, titrate with 0.1 molar NaOH. Suppose at the end point, the reading is x2 ml of NaOH. Then you will carry out a blank determination. Another conical flask, 40 ml of 30% sodium benzoate solution, few drops of thermal blue indicator. And suppose at end point, the reading of NaOH solution is Y2 ml. So this Y2 ml has been consumed by our sodium benzoate solutions, which is of course few ml, or you may say a very small volume is there. So that Y2 will be subtracted from X2. So X2 minus Y2, this much volume of NaOH has been consumed by your drug. Using the same factor of pharmacopoeia, 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram of furosemide. You can find out the drug content. Now you see the difference between the two methods. IPBP method involves the use of a class 2 organic solvent dimethyl formamide, okay, of which the vapor they are very harmful for human being, and of course dimethyl formamide is costly also. But when it has been replaced by sodium benzoate solution, now we see the cost of sodium benzoate solution 30%. The cost is about rupees 40 per liter. Rupees 40 per liter is the cost of sodium benzoate solution. Okay, another thing, advantage. Sodium benzoate does not evaporate out, it will not go in your body, okay. And of course, the same results are there. This I have shown in IPC Ghaziabad lab also. In my presence, they have conducted this, and of course, the both methods, pharmacopoeial method and my method, means hydrotrophic, they were giving the same result. Okay. Now, of course, here, as you are seeing that what we have done here by using this sodium benzoate solution, you have minimized, you have removed dimethyl formamide in your this operation, trichromatic operation, of course. And one day will be there when you will have an IPBP, etc. These are same methods will be utilized to replace these organic solvent. Now coming to another, of course, now in the same way, flurbiprofen API, it involves the use of ethanol, class 3 organic solvent. Now this has been replaced by sodium benzoate solution in the same way. Naproxen uses methanol in IPBP method. This methanol has been replaced by sodium benzoate solution in the same way, and this method also has been checked in my presence in IPC Ghaziabad lab. Same results were there. Salicylic acid uses ethanol in IPBP method, sodium citrate. This is another hydrotrophic agent which was employed in salicylic acid because this is good hydrotrophic agent for salicylic acid. It is also cheaper. Then ketoprofen involves use of ethanol. Ethanol has been replaced by sodium benzoate. Ibuprofen uses ethanol, has been replaced by sodium benzoate solution. Ibuprofen tablet, now here there is involvement of two organic solvents, chloroform and ethanol. Now these both organic solvents, of course the procedure you can read afterwards. Okay, now this procedure is where IPBP method is same. In IP 2022 also the same method is there. Involvement of chloroform, first extraction with chloroform. Chloroform is removed in air current, residue is dissolved in ethanol and it is titrated. Now you see both these organic solvents have been replaced by sodium benzoate solution. This method will just 10 minutes briskly shaking with sodium benzoate solution will be there. Due to this shaking, now the sodium benzoate solution will dissolve the ibuprofen present in the tablet powder, and then you will carry out the titration using sampling indicator. Okay, and of course filling determination is carried out. So what you are doing, very cheap method and very, you can say, the safe method. Sodium benzoate does not evaporate out like that. So many things they have been means a large number of drugs I have titrated them with the help of hydrotrophic solutions without using organic solvent. Now after this, coming to UV spectrophotometric estimations of pharmaceutical dosage forms of poorly water soluble drugs using hydrotrophic solutions without organic solvent. Now here the example is that of tindazole tablet. Here, of course, let me read this procedure completely. IPBP method 2022 IP, the same method is there. B tablet powder equivalent to 0.15 gram of tindazole plus 20 ml methanol and shaking. Volume is made up to 100 ml with methanol, so methanolic procedure. Then you have to filter out to remove insoluble excipient. Then from filtrate, 10 ml filtrate is taken and diluted up to 100 ml with methanol. Then from this solution again 10 ml is used to get and it is diluted up to 100 ml with methanol. Then the absorbance of this solution is noted at 310 nm in methanol. In methanol, the peak of tindazole comes at 310 nm, 310 nm. Tindazole is poorly water soluble drug, so IPBP method they have used methanol and calculate the content of tindazole taking 356 as the expensive absorbance at 310 nm. So using this E1% 1 centimeter value, you can find the drug content of the tindazole tablet. So what you are doing, you are using methanol. Total method is methanol. Now without methanol, how will you carry out this? B tablet powder equivalent to 50 milligram of tindazole, add 20 ml of 30% aqueous solution of sodium benzoate and shake for 10 minutes in a 25 ml volumetric flask. So 10 minutes shaking. During this shaking, sodium benzoate solution dissolves ibuprofen present in the tablet powder. Make the volume up to 25 ml with the distilled water. Now you are not diluting with sodium benzoate solution. No, only once you are applying sodium benzoate solution. Remaining dilutions with water. So make the volume up to 25 ml with the distilled water and filter it to remove insoluble excipient. Then dilute 1 ml of the filtrate up to 100 ml with the distilled water. And now the absorbance of this solution is noted at 318 nm. In water, the P comes at 318 nm against reagent blank. How this reagent blank is made? You will take 25 ml volumetric flask, 20 ml sodium benzoate solution 30%, up to 25 ml with water, 1 ml, diluted up to 100 ml with water. This contains same amount of sodium benzoate which is present together with your drug in your sample solution. So sample solution will be put in the sample cuvette and this reagent blank solution will be put in the reference cuvette. You will note down the absorbance. So absorbance will be due to your drug only, sodium benzoate. In effect, they are neutralized in both the cuvette. Same amount is there. Okay, now we have noted the absorbance. Now we have to find out the drug content. How will you find out the drug content? What you can do, calculate the drug content of from the absorbance obtained by repeating the whole procedure using 50 milligram tindazole RS. RS means reference substance in place of tablet powder made. You will have to utilize a pure sample of tindazole which you take from some companies. It is written on its label that it contains 99.21% of drug. So based on this, you will take 50 milligram of tindazole, 25 ml volumetric flask, 20 ml sodium benzoate solution, dissolution, further dilution water up to 25 ml, 1 ml, dilute up to 100 ml with water. So of this solution, you will note down the absorbance against reagent blank. Reagent blank is common for all these both operations. And then by comparing these two absorbances, you can find out the drug content. Or another way, you can make a calibration curve, 5, 10, 15, 20, 25 mg per ml solution, respect to reagent blank. Using this respect to reagent blank, you can find out the absorbances and then you can plot a calibration curve. And from that also you can calculate the tindazole tablet, means the drug content of tindazole tablet. Now what is the beauty of this method? You are not using methanol, which is volatile and it goes in your body whenever you perform this step. What you are doing, you are using sodium benzoate solution. Sodium benzoate does not evaporate out. No, it is cheaper also. The cost of sodium benzoate solution 30% I have told it is rupees 40 per liter nearly, but the cost of methanol may be 200, 250 rupees per liter. But main thing is that you are preventing the human being against the exposure to the vapors of methanol. So in this way, what you are observing that in this UV method also you can utilize the hydrotrophic solubilization to replace harmful organic solvent. Similarly, in case of naproxen tablet, methanol IPBP method has been replaced by sodium benzoate. One thing let me tell you, sodium benzoate does not interfere in UV analysis above 292 nm. 292 nm above, it does not you may interfere in the UV analysis, as in case of tindazole 380, in case of naproxen tablet 331 nm, no interference of sodium benzoate. Indomethacin capsule, methanol will be replaced by sodium benzoate solution. Here estimation is done at 320 nm. Diazepam capsule, methanol has been replaced by mixed hydrotropy. In here the estimation is done at 354 nm. Whenever you use sodium benzoate, do not use before 292 nm. Okay, otherwise you will not get good results of your analysis. Always you will use sodium benzoate in those cases where the drug peak is away from 292 nm. Now, before 292 nm, suppose you want to carry out the work, for example, in case of atenolol tablet. Atenolol peak comes at 275 nm, 275 nm. So here, you cannot use sodium benzoate here. So in this case, urea solution, hydrotrophic solution of urea has been employed in atenolol tablet estimation to replace methanol, which is utilized in IPBP. Methanol is removed by, has been replaced by the solution of urea, because urea does not interfere in UV analysis above 240 nm. Above 240 nm, urea does not interfere. Those who are interested for all these, for any question answer, please note down question at the end of the lecture. Have question answer session. Dichloronic sodium tablets, IPBP method involves use of methanol, but this methanol has been replaced by urea solution by estimating this dichloronic sodium at 276 nm, which is away from 240 nm. Urea does not interfere. Now, after this, coming to TLC, first you listen my sentence that for each and every compound, you can use, you can perform the thin layer chromatography of each and every compound. Each and every compound means whether your compound is water soluble or your compound is water insoluble without the use of any organic solvent, using hydrotrophic solution or using mixed hydrotrophic solution, etc. Now here, see, this is a published paper reference. It is available online on the Google search. So in this particular work, 3 M.Pharm students, they have carried out work. 9 water-soluble drugs, they were selected. 9 water-soluble drugs were selected, like propanol, hydrochloride, guaifenesin, etc., up to this low sodium potassium. Then students made a 2% aqueous solution of these drugs individually, means 9 drugs, 9 solutions, 2%. Using capillary, the spot was put on the silica gel heat plate. It was heated to remove water to fix the spot. Then TLC was carried out. TLC was carried out using different blends. 8 blends were made. I told the 3 M.Pharm students to make 8 blends at random. Blend 1 was containing 5% sodium benzoate, 5% sodium acid combined, mixed hydrotrophic solution. And this will be used to carry out the for the development of TLC plate. Blend 2, 5% sodium benzoate, 5% niacinamide. Blend 3, sodium benzoate 5%, sodium citrate 5%. Blend 4, 10% sodium benzoate solution alone. Blend 5, sodium acetate niacinamide, sodium citrate niacinamide, like this. And 8th blend was this for propanol hydrochloride, 7.5% niacinamide and 7.5% sodium benzoate. I told the students to carry out for each drug, 8 blends will be used to carry out the TLC work. Development of plate, then heating to remove water, and identification using iodine chamber. I told the student, you select such blends which give good spot without tailing effect. So you see, in case of propanol hydrochloride, only 1 blend was found suitable, 7 were unsuitable. 1 blend, 7.5% niacinamide, 7.5% sodium benzoate are available as 0.8 without tailing effect. In case of guaifenesin drug, blend 1, 2, 3, 4, and 7, they were found good without tailing effect, like this. So in this way, TLC was carried out. Now you see, up to this time, whatever the TLC you will see, all TLCs they utilize either 1 or 2 or more organic solvent. Like in case you see for 5 drug IP method, you see ciprofloxacin and hydrochloride IP method. It utilizes dichloromethane, methanol, acetonitrile, which are class 2 organic solvent. Guaifenesin involves the use of carbon tetrachloride, class 1 organic solvent. Ethanol, class 3 organic solvent, like this. Piperazine, like, and so these are the examples. So what can we do now? We can perform thin layer chromatography of each and every compound using hydrotrophic solution, mixed hydrotrophic solution, without the involvement of any organic solvent. Okay, so what we are learning here, we are learning that by utilizing the solubilizing power of solids, we are carrying out the thin layer chromatography of substances without using any organic solvent. Now coming to HPLC. In HPLC, there are limitations for water insoluble type of drug. Means for all water soluble compounds, reverse phase HPLC can be performed using hydrotrophic solutions or mixed hydrotrophic solutions. But for poorly water soluble drug, there are limitations because concentrated hydrotrophic solutions cannot be used as mobile phase. Otherwise, they will block or they will harm. They will give harm to the columns, like this. Okay. Now we listen one sentence from me. For each and every water soluble compound, reverse phase HPLC can be performed using smaller concentrations of hydrotrophic agents or mixed hydrotrophic solutions to carry out this reverse phase HPLC. Okay, without any organic solvent. Otherwise, whenever you will see any HPLC method, it involves the use of organic solvents, particularly methanol, acetonitrile. They are used in reverse phase HPLC, in all these HPLCs and all that. Now we see this example here. This is a reference of a work done on cefixime tablets by Remy Madam, Remy SL. In Kerala, she is assistant professor. She has done PhD work on hydrotrophic analysis, UV analysis, and HPLC. She has carried out this work. So this is her work. So this is a published paper. It is available online. What has been done here? Cefixime tablets analysis was carried out using hydrotrophic solution of sodium acetate, 6%. Okay, so this was used as mobile phase to carry out this work. Details you can see from the published paper. Another article published by same Remy Madam. She has analyzed tablets containing two drugs combinedly, paracetamol and diclofenac. These tablets were analyzed by Remy Madam by reverse phase HPLC using 5% urea solution as mobile phase by reverse phase HPLC. Published paper reference is there. It is available online. So here, what you are saying that without the use of any organic solvent, you are able to perform the reverse phase HPLC. But I told you that if you want to carry out this work, you should select a water soluble compound, because for all compounds, whether it is water soluble or insoluble, always these HPLCs, they will utilize organic solvent as mobile phase and all that. But in this case, in case of water soluble drug, always you can utilize hydrotrophic solution or mixed hydrotrophic solution as mobile phase without any organic solvent. But only thing will be you will have to do trials and error. Some 4-5 trials you will have to carry out using different concentrations or different blends of mixed hydrotrophic solutions and so as in the usual case also. Suppose in usual case also for a new drug, if you want to develop HPLC method, you have to carry out different using different the mobile phases and all that. Now mixed hydrotrophy. From hydrotrophic solubilization, single hydrotrophic solubilization is more than 100 years old concept, but no one has employed mixed hydrotrophic solubilization. And what is this mixed hydrotrophic? This in the year 2008 we have started from, of course, from Indore, you may say, or from my lab. This work has been done. I have given this work to 3 M.Pharm students. Using this mixed hydrotrophic solubilization, the solubility was enhanced. And why? What is the reason why mixed hydrotrophy was used by me? The reason was, since you see, when you will see a Lakeman for hydrotrophic solubilization, a sentence you will get from that book of Lakeman that since a large concentration of hydrotrophic solution or hydrotrophic agent is used to enhance the solubility of a poorly water soluble drug to develop its reduced form. So because of the toxicity of large concentration of single hydrotrophic agent, the concept has not been used much in the formulation. So I have employed this mixed hydrotrophy particularly to develop the marketable formulations. So from 100 years, so many persons they have developed the various injections, etc., but they could not be marketed. Why? The reason you will see from this list. This list is that of additives which I have taken from Inactive Ingredient Guide 2020. This is 2019 book. So it is wrongly written 2020. 2019 book, Inactive Ingredient Guide. It is a book which gives the concentrations of different additives which can be employed safely in various formulations. And pharmaceutical manufacturers, they refer this book to select the drug, this concentration of additives. Okay. From this book, I have brought these agents and these concentrations which are mentioned here. In these concentrations, these are the additives which can be safely employed in intramuscular injection, aqueous intramuscular injection. You are seeing additives for aqueous intramuscular injection. Now you see, from this you see, if you see this number 13, this is sodium benzoate 10%. Now from where this has come 10% from Inactive Ingredient Guide. Means above 10% you cannot employ. If you will employ, then you will have to carry out so many studies. Then you can employ 12% or 15% sodium benzoate. Okay. So up to this time, more than 10% sodium benzoate could not be employed in marketed formulation. Okay. Now you can see that suppose some scientists they have developed the aqueous intramuscular injection of poorly water soluble drug using say 30% sodium benzoate solution. But these formulations cannot be marketed because they contain higher concentrations of sodium benzoate. Now you listen to me. Now you can make marketable formulation if you implement mixed hydrotrophic solubilization. Now you see number 13 is sodium benzoate 10%. It is safe and aqueous intramuscular injection. Now we see number 8 sodium acetate 10% and number 2 sodium citrate 10%. So three things, three hydrotrophic agents, sodium citrate 10, sodium acetate 10, sodium benzoate 10. 30% solution you have made. It is a mixed hydrotrophic solution. And in the solution, if you check the solubility of your poorly water soluble drug and if it is enhanced to the desired level, you can make it some marketable and aqueous intramuscular injection. Of course, after all chemical stability studies and all that, but this formulation can be marketed. But otherwise, you cannot market your formulation in large concentration of single hydrotrophic agent. So this was the reason to start this mixed hydrotrophic solubilization. And from the same table, let me explain other thing also. After mixed hydrotrophy, what I want to discuss now here. Now, I told you I have started a new concept known as mixed solvents concept in the year 2009. There are two parameters of that concept. Number one parameter says that each and everything present in the in this universe has got solubilizing power. Which whatever the molecules are there in this universe, all molecules possess solubilizing power. Number two, since all molecules possess solubilizing power, so there may be solubilizing power in your additives which you employ in various formulations. There may be solubilizing power in them also. Okay, so this second parameter says that you may imply smaller concentration with safe concentrations from the point of view of toxicity. You can make a concentrated solution, and that concentrated solution that can be used to enhance the solubility of poorly water soluble drug to make its aqueous intramuscular injection. For example, you see from this small list, you can make innumerable safe solvent system. For example, if you mix three things, number 1, 2, 3, alcohol, sodium citrate, arginine, 30% solution is ready, and it is safe in aqueous intramuscular injection from the point of view of toxicity. Okay, so this is one blend having definite solubility of some drug. Suppose you change arginine by histidine, another blend of 30% is ready. So by permutation combination, using different, you can differ the concentration, but keeping them in the safe range. You can mix 4, you can mix 5, and you can make concentrated solutions. And when solubility of drug is enhanced to desired level, you can make this aqueous intramuscular injection. So what you are learning from this small table, that by using mixed solvency concept, you can make innumerable safe solvent system for aqueous intramuscular injection. Similarly, you can make safe systems for syrups, for topical solutions, and so on and so forth. Now, coming to mixed hydrotrophy, then again, now we will proceed to. Now you see here, this is example. You can see later on that how the mixed hydrotrophy was utilized here. Now this is the second parameter mixed solvency concept. Here, what I have done, I have made a solution mixed solvent system. I have made sodium benzoate, sodium caprylate, sodium citrate, Polacman 407, 55%, total 20% in water. pH was 7, which is neutral. In this particular mixed solvent blend, I have checked the solubility of several poorly water soluble drugs, and two examples I have brought for you. They are that of furosemide, pyroxicam. Furosemide solubility in this particular blend is 35 milligram per ml nearly, and in water its solubility is even less than 1 milligram per ml. So at least 35-fold solubility enhancement is there. What is the reason for this? Here 4 solids, sodium benzoate, caprylate, citrate, or Polacman. Their molecules are in liquid state and they are involved in hydrogen bonding and weak bond forces with the molecules of your this drug. That's why you are getting a large solubility in this particular blend. Now, utilizing this mixed solvency concept, what you can do? You can make their ready-made aqueous injection. You can make their dry powder injection for reconstitution. Suppose a drug D is there. For example, suppose a drug D is there and D has got the same solubility in water 1 milligram per ml and it is blend 35 milligram per ml. Just we have to assume. Okay, and it is hydrolyzable drug. Drug D is hydrolyzable drug. It's a dose in tablets, marketed tablet 20 milligram. So suppose you want to make 20 milligram per ml this injection of this drug D, which is hydrolyzable. You cannot make it a ready-made injection. Okay. But suppose you make it a dry powder injection for reconstitution, you can have a shelf life of 1.5 years, 2 years, 2.5 years, etc. Okay, at the time of need, you will add water and you will shake it, and you will get clear solution. How? Now we see here from this list, 5% sodium benzoate means 100 ml 5 gram, 10 ml 500 milligram, 1 ml 50 milligram. So in 1 ml, 50 milligram of all these 50, 50, 50, 50, 50, they were kept in vial in solid state after sieving to fine sieve. 20 milligram drug D, which is hydrolyzable, has been kept here in this vial. And now the stability of this is, it is safe, means its shelf life is more. At the time of need, you will add 1 ml water per injection. You will reconstitute, you will get a clear solution. Because of solubilizing power of these four solids, you will have clear solution. You will not get suspension. You will get a clear solution, and it can be injected. So anyway, there are so many applications. Different other applications of mixed solvency concept. You can, this is the same, you see in this particular MPAR project, published paper reference is there. In the certain lactation, 8 milligram drug has been dissolved by 100 milligram sodium capryate, 50 milligram sodium benzoate, 50 milligram sodium acetate. Kept in vial, reconstitution 1 ml, you will get clear solution. Published paper they are all there. And of course, those who need the soft copy of M-Pharm thesis, I can send the soft copy of M-Pharm thesis to students or teachers or researchers. I can send. So, okay. Now you can use mixed solvency concept to develop solid dispersion without the use of organic solvent, of course, utilizing the solubilizing power of solid additives. So here you see in this particular M-Pharm project, torsemide drug, insoluble drug was selected. 2.5 gram was dissolved with the help of 1.25 gram sodium citrate, 1.25 gram sodium acetate, 2.5 gram beta cyclodextrin, and 5 gram sodium capryate. They were first, these four carriers were dissolved in water, then drug was dissolved, then water was evaporated out by heating, stirring, and all that. After complete drying, it was sifted through fine sieve. So this is a mixed solvent system. The solid dispersion made by mixed solvency concept. So it will go fast release of drug. Okay, like this. Coming to liquid solid system, this mixed solvency concept is very useful in development of liquid solid systems. Why? Because you see, in liquid solid system, we select non-aqueous solvents like propylene glycol, PG400, glycerin, etc. Okay, PG400, etc. And in this, we dissolve the drug, and then this solution is adsorbed, adsorbents like MCC, etc. And it is made free flowing, then it convert into capsule or tablet. So you see, if the solubility of your drug, if it is less in your this non-aqueous solvent, then you cannot make it a free flowing powder to make it a tablet. But using mixed solvency concept, you can potentiate or you can improve the drug loading in your solvent, non-aqueous solvent system, reducing its you may say the volume and hence the weight, so that after adsorption to make free flowing, you can make it a tablet or capsule. For example, here this is the M-Pharm project of one student, M-Pharm student. It is published paper online. What has been done here? Pyroxicam, which is poorly water soluble drug, has got very poor solubility in propylene glycol, which is non-aqueous solvent system selected by the student. So the solubility was only 5 milligram per ml nearly. So for making its dose 20 milligram, you will require 4 ml. 4 ml of propylene glycol means 4 gram nearly. So you cannot make it a tablet after adsorption. But what has been done? Two solids were implied to improve the solubilizing power for pyroxicam in propylene glycol. What are these two solids? 10% sodium acetate, 10% sodium capryate. And they were dissolved in propylene glycol. The solubility of pyroxicam in this mixed solvent system was more than 120 milligram per ml. So 120 divided by 5, 24-fold enhancement in solubility was there. Now we see this 120 milligram per ml with the solubility in this blend. Now we see, suppose it is 100 milligram per ml. So 100 milligram 1 ml, 10 milligram 0.1 ml, 20 milligram 0.2 ml. 0.2 ml solution contains 20 milligram of your drug. 0.2 ml means nearly 0.2 gram. Means 200 milligram adsorbed by about 600 milligram MCC. 800 milligram free flowing powder can be converted into tablet or capsule like this. So in this way, mixed solvency concept is very useful to develop the liquid solid system in industry. Industry persons, they cannot make a liquid solid system of all poorly water soluble drugs unless they utilize the mixed solvency concept. They not make for each and every compound, but liquid using mixed solvency concept for each and every poorly water soluble drug, you can make a liquid solid system. Aqueous injection, dry powder injection for reconstitution. This is another work, MFAR project work. Then these I am leaving. Vaginal film size was reduced using mixed solvency concept by increasing the drug loading. So this MFAR project can be seen by the student. Improvement of drug loading in SCDDS. Improvement of drug loading in oral film using mixed solvency concept. These all are the MFAR project work published, and soft copy I can send to you if you require. This is another work on oral film. Size was reduced by increasing the drug loading utilizing solubilizing power of additives. Melted solids as solvent. Now this is a very interesting thing. So let me explain briefly. Now you see the reference of this published paper, eco-friendly extraction using solid. In novel application of mixed solvency concept, published paper reference is there. What has been done? Let me explain you. Sesame oil was selected as, you may say, the active constant which is present in the sesame seed powder. The solubility of sesame oil was checked in melted thymol. 1 gram thymol in your test tube water bath at about 50 degrees centigrade with the melting point of thymol. Thymol has been converted into melted thymol liquid, means 1 gram clear colorless melted thymol liquid, 0.1 ml sesame oil, dissolved 0.1 ml sesame oil. More than 1 ml sesame oil is nicely dissolved by melted 1 gram melted thymol liquid. Okay, thymol, it can be evaporated out at about 60-70 degrees centigrade. So knowingly, I utilized our team, of course, MFAR student team was there. They have utilized melted thymol as solvent system to carry out the extraction of sesame oil from sesame seed powder. How this extraction was carried out? 3 gram sesame seed powder in your test tube. 3 times means 9 gram thymol. 3 gram sesame seed powder, 9 gram thymol. Water bath at about 50 degrees centigrade, thymol melted. Shaking 30 minutes, again heating, shaking 30 minutes, shaking. Caused the dissolution of, or the extraction of sesame oil from sesame seed powder. Then straining through cloth. Strained liquid containing melted thymol containing dissolved sesame oil was exposed to about 60 to 70 degrees centigrade in oven for the removal of thymol. Then remaining was in about 1 hour. Thymol was removed, remaining was sesame oil. I am not saying that thymol is economic or like that, but what I want to tell you, just I want to say for the, you may say, the researchers, that solids can also be employed for the extraction of active constant from herbal powder. Of course, there are so many details, but I cannot say in brief time, of course. Similarly, melted menthol was employed for extraction. It was also removed by heating. At room temperature, ethanol was made a strong solvent for sesame oil. Using this thymol 50%, it was a strong solution. At room temperature, 9 ml this solution, 3 grams sesame seed powder. It has dissolved sesame oil, filtration, and heating at 70 degrees centigrade. Ethanol was removed, thymol was removed, like this. So in this way, just of course, so many details are there which can be explained to you later on. So in this way, just to show the researchers that we can employ the solubilizing power of solids for extraction also. Okay, now coming to directly towards end. Now I have made already I have made 7 YouTube videos are there. Each video is that of about 40-45 minutes duration. If you put these words eco-friendly lecture series number 1, you will get this particular video in which you will find eco-friendly and economic UV spectrophotometric analysis of poorly water soluble drugs by application of hydrotrophy, mixed hydrotrophy, and mixed solvency concept without the involvement of organic solvent. If you put these words, eco-friendly lecture series number 2, eco-friendly and economic titematic analysis of poorly water soluble drugs by application of hydrotrophy, mixed hydrotrophy, and mixed solvency concept without the involvement of organic solvent. Number 3 is for mixed solvency concept. Each and every substance, whether gas, liquid, or solid, present in this universe has got solubilizing power. Of course, as per mixed solvency concept. Eco-friendly lecture series number 4 is for TLC of compounds. Number 5 is for reverse phase HPLC of the compound. Number 6 is for dry powder injection for reconstitution. as these, you can make the dry powder injection for reconstitution. You can also employ the mixed solvency concept to make dry powder syrups for reconstitution. You can make, so you can apply these mixed solvency concept in so many formulations. If you put the water 7, number 7, this gives the application to make innumerable safe, you may say eutectic liquid. Eutectic liquids, they may act as solvent in vast field of science, for example, extraction, for analysis, for synthesis and all that. Of course, it is an art, because using this video, you can make innumerable, say, you may say this eutectic liquid use of solids like this. So anyway, so many things are there. Now coming to the end, that is thank you, and of course here it gives the mobile number, WhatsApp number. If you have any query after today, then also you can connect with me. You can ask me by phone, you can ask me by email ID. These all are given here. Okay, so what I want to say that more and more researchers, they should utilize this mixed solvency concept, particularly the use of solubilizing form of solids to develop these formulations and for analysis and extraction. Of course, in pharmacology also there is, let me explain that this mixed solvency concept can be used in the field of pharmacology also when toxicological studies or therapeutic studies, they are done in small animals. Sometimes DMSO is used for the dissolution of drug, and the researcher knows that DMSO should not be used, but because of good solubility, DMSO has been preferred. You can replace DMSO by safe, you may say this mixed solvent system, as I have explained in the case of aqueous intravascular injection. So means in pharmacology, in all fields you will find the applications of mixed solvency concept. Now my lecture is over. I am stopping the sharing, and then I am coming to you. If you have any questions, please ask. Yes, okay.
Thank you, sir. Thank you, sir, for your wonderful and informative lecture. And definitely, this will help to the young researcher to work on this field. So it is requested to all the listeners and viewers, if you have any questions, then please put any the chat box, and we will try to answer them as after the consultation of Professor R.K.Maheshwari, sir. So I am requesting to our director, sir, to please say something about our lecture.
So thank you very much, sir. Very excellent lecture. I have taken near about the 20 of the screenshot. So this is the actually practical approach, and you have given the each and everything in a scientific manner and all data what we are the performing in the laboratory. So this is the excellent technique and how we can apply not only for the solubility, for the determination of the compound, and it have the number of the application in the various purposes, and to avoid the and how we can reduce the organic solvent and how we can move toward this direction. I feel that in the coming days this types of the technology is the commercialized, and most of the peoples and industry person they can also utilize, as we know that when we can use some of the natural substance, then they are the less tasty and need the time, and when we are using the artificial, they are the looking good and sometimes more tasty, but they are the too much harmful. So that is why our government of India and Prime Minister Shri Narendra Modi ji is the mention that no defect and no effect. Nowadays, this type of the technology is required. What are you producing in the industry, and for the society, it will have the no defect, and it also not produce any effect on the atmosphere, because everybody worry about this one. That is why avoid the organic solvent and move towards such types of the technology, so that it will be the very less harmful to the environment, and you can say individuals also, because when we are the working in the more and more solvent, then it can be through the respiratory system, it can be sometime harmful. So I hope that in the coming days we can also connect with the Dr. Maheshwari ji, and physically he will be over here, and I feel that we can interact and also establish one of the unit just like of the this one, so that one of our research team they will work in a particular area. Sir, we have the here is the 39 laboratories, and our research team of the total 68 members they are working over here, and near about we are the running of the 15 projects obtained from the various agencies. Recently, we have received the 3 MSME project, only 3 MSME project approved in the Punjab and all 3 in the ISF College of Pharmacy. So I am not giving the any more information like that. That this is the one of the biggest of the research institute. But yes, we have the one of the strong, dynamic, and young team. They have the dedication to the work. That is why the results in the all surrounding ISF College of Pharmacy doing like this types of the work, and our management, including myself, to connect this types of the person so that we can approach like this one. My suggestion over here, sir, you have given number of the things, so I want in the coming hackathon 4.0, if MSME launch some of the idea like that, I request to you, you can submit 2 to 3 idea for this purpose, so that it will be the helpful to the industry, because I know that if we can obtain some of the fund, we can scale up the technology, and after the scale up the technology we can transfer to the industry, or we can the sell out, so it will be the useful to the society also. In those days, small medium MSME, they are producing, giving the 15 lakhs to the 20 lakhs for the initial level, and if the idea it will be the approved and the product it will be the finalized scale up like that, then there is the no limit about to the 1 crore rupees and more than this. So I hope that we can connect with Dr. Maheshwari ji, and with the connection we can establish one of the place over in ISF College of Pharmacy, especially name of this one, related to the solubility and related to the without any organic solvent, how we can improve the solubility of the poorly water soluble drug, and how we can develop of the analytical technique using these types of the substance. So again, मैं सहृदयता से आपका बहुत बहुत धन्यवाद करता हूँ, and I also feel that you are the very very down to earth. Only a few of the peoples of the you can say scientists, those who are the down to earth and doing the work for the society, for the student, and for the profession also. So thank you very much. I am thankful to the Dr. Balak ji for provide this opportunity, and also thankful to the ISF Dialogue Series coordinator Dr. Mann for continuous efforts to doing and executing these types of the activity. Thank you very much, sir.
Thank you, sir.
थैंक यू, बहुत बहुत धन्यवाद। और मैं आपसे जुड़ूंगा, आपके यहाँ के रिसर्च वर्क से जुड़ूंगा, मैं आपसे और बात करूंगा अलग से। अभी आपका रिकॉर्डिंग चल रही है, मैं बाद में और बात करूंगा आपसे, है ना?
Most welcome, sir. Most welcome. Thank
बहुत
you.
बहुत धन्यवाद।
Okay, thank you.
May I leave?